Every day, before sunrise, thousands of components begin a carefully coordinated journey inside one of the world's most advanced truck manufacturing systems. Massive steel structures arrive from suppliers, powerful engines wait for installation. Robotic arms prepare for another day of precise work, and by the end of the process, one of the most respected trucks on the planet will be ready to leave the factory floor. This is Scania, a company known worldwide for producing some of the most reliable heavy-duty trucks ever built. From long-haul transportation across Europe to demanding construction sites and harsh industrial environments, Scania trucks are designed to perform under extreme conditions while carrying enormous loads. But creating one of these machines is far more complex than most people imagine. Before a truck ever touches the road, it passes through a manufacturing process involving thousands of individual parts, advanced robotics, highly skilled workers, and some of the strictest quality standards in the automotive industry. Every bracket, every bolt, every cable, and every electronic system must be installed with absolute precision. Even the smallest mistake can affect performance, safety, and durability. That is why Scania has built its reputation around a single principle: quality above everything else. Today we're going inside one of the largest and most advanced Scania production facilities to follow the complete journey of a truck, from a simple steel frame to a fully operational heavy-duty machine. We will witness how the chassis is assembled, how powerful engines are installed, how truck cabs are manufactured by robots, and how every completed vehicle undergoes rigorous testing before it is approved for delivery. Behind every Scania truck stands a combination of engineering, technology, and decades of manufacturing experience. This is not simply an assembly line. It is a carefully choreographed industrial system designed to produce machines capable of traveling millions of kilometers throughout their working lives. And it all begins with a pair of steel rails that will eventually become the backbone of a giant. Everything begins with the frame. At first glance, it appears simple: two long steel beams positioned side by side. But these beams will eventually support every major component of the truck: the engine, transmission, suspension, fuel tanks, cab, and cargo body will all depend on this structure. For that reason, the frame must be exceptionally strong and precisely assembled. Inside the first production workshop, workers begin constructing the chassis using Scania's modular manufacturing philosophy. This concept is one of the company's greatest strengths. Instead of designing completely different structures for every truck model, Scania uses standardized components that can be combined in numerous ways. This allows the factory to build vehicles for many applications while maintaining efficiency and quality. Large brackets and mounting points are attached to the frame. These components may appear insignificant, but they serve as connection points for systems that will be installed later in production. Each part must be positioned with extreme accuracy. A deviation of only a few millimeters can create serious alignment problems further down the line. Throughout the process, inspection teams constantly verify measurements and assembly quality. Nothing moves forward until it meets strict specifications. Some of these chassis are designed to carry loads approaching 48 tons. Others will become dump trucks, concrete mixers, logging trucks, or specialized industrial vehicles. Although their final purposes differ dramatically, they all begin their lives on the same production line. This flexibility is one of the reasons Scania has become a global leader in heavy-duty transportation. As the frame progresses through the workshop, it slowly transforms from raw steel into the foundation of a future machine. More components are added, and the structure becomes increasingly complex. By the time it leaves this section of the factory, the truck's backbone is complete. But a frame alone cannot move. It needs brakes, wiring, hydraulics, and suspension systems before it can continue its journey toward becoming a Scania. The next stage is about to bring this giant one step closer to life. With the chassis complete, the truck enters the next stage of its transformation. At this point, the frame is still little more than a skeleton. It has strength, but it lacks the systems that will eventually bring it to life. Inside the second assembly workshop, workers begin installing one of the most important elements of any modern vehicle: its nervous system. Hundreds of meters of electrical wiring are carefully routed throughout the chassis. Alongside them come hydraulic hoses, air lines, control cables, valves, and electronic connections. Each component has a specific destination. Every cable must follow an exact path. Every connection must be protected from vibration, moisture, and years of heavy use. The complexity is astonishing. Modern trucks contain advanced electronic systems responsible for braking, lighting, engine management, diagnostics, safety features, and communication between different modules. A single error in the installation process could affect the operation of the entire vehicle. This is why every stage is continuously inspected. Defaults as the wiring progresses. Another critical system begins to take shape: the braking system. Scania trucks use a dual-circuit pneumatic braking system designed to provide maximum reliability under demanding conditions. Compressed air travels through a network of precisely installed lines, allowing the truck to generate tremendous stopping power, even when carrying extremely heavy loads. Many customers also choose advanced electronic braking technologies that help distribute braking force more efficiently between the axles. The result is greater stability, improved safety, and shorter stopping distances. Once the braking components are installed, the assembly line moves forward again. Now the truck begins receiving its suspension components, wheel hubs, steering assemblies, and axles. This stage dramatically changes the appearance of the vehicle. For the first time, the chassis begins to resemble a truck. Different customers require different capabilities. Some vehicles are designed for highways. Others must operate on construction sites, forests, mining roads, or rough terrain. To meet these demands, Scania offers multiple wheel configurations and axle layouts. Each configuration is engineered to balance payload capacity, fuel efficiency, maneuverability, and durability. Slowly, the machine is taking shape, but the most important component has yet to arrive. The component that will eventually provide the power needed to move dozens of tons across continents: the engine. 4 hours. The truck has been growing piece by piece. Its frame is complete. Its wiring is installed. Its axles are in place. Yet despite all this progress, it remains motionless, because the heart of the machine is still missing. Then comes one of the most important moments in the entire manufacturing process: the installation of the engine. Massive power units arrive at the production line already assembled with their transmissions. Using specialized lifting systems, technicians carefully lower the engine into position. The operation requires absolute precision. A modern truck engine weighs hundreds of kilograms and must align perfectly, with numerous mounting points across the chassis. Once secured, the engine rests on specially designed vibration isolating supports. These components absorb mechanical forces generated during operation and improve comfort for the driver. But installing the engine is only the beginning. Soon workers begin connecting dozens of additional systems: cooling lines, fuel systems, electrical networks, exhaust components, transmission controls, air intake systems, and electronic control modules. Every connection must function flawlessly, because once the truck leaves the factory, it may spend years operating in some of the harshest environments imaginable. Scania engines are built specifically for heavy transportation. Unlike high-performance sports car engines that prioritize speed, truck engines are engineered for torque, massive amounts of torque. This allows the vehicle to move enormous loads while maintaining efficiency and reliability. Many of these engines also meet strict Euro 6 environmental regulations, reducing emissions without sacrificing performance. As more components are added, the transformation becomes increasingly dramatic. Radiators are installed, fuel tanks are mounted, battery compartments are secured, exhaust systems take shape. For the first time, observers can clearly recognize the outline of a future truck. What began as two simple steel beams is now becoming a sophisticated machine. Yet one major component is still missing: the driver's workplace, the cabin, and its journey begins hundreds of kilometers away inside one of the most advanced cab manufacturing facilities in Europe. While the chassis is being assembled, another extraordinary manufacturing process is taking place elsewhere. In Oskarshamn, Sweden, Scania operates one of the most advanced cab production facilities in Europe. Every day, approximately 160 tons of galvanized steel arrive at the factory. To most people, these giant steel rolls appear ordinary, but within hours, they will begin transforming into one of the most recognizable truck cabs in the world. The process starts in the press workshop. Powerful machines cut, shape, and stamp steel sheets into hundreds of unique components. Each cab consists of more than 300 individual metal parts. Every panel, reinforcement, support structure, and frame element must be manufactured with exceptional precision. Once formed, the components move to the welding area. Here, dozens of robotic systems work together in perfect synchronization. Arms move rapidly through the air. Welds appear in fractions of a second. Panels are joined together with astonishing accuracy. The scene resembles a futuristic ballet performed by machines. Yet behind this choreography, advanced engineering and years of process optimization. Gradually, individual components become larger assemblies. Larger assemblies become complete structures. And eventually, a fully formed cab emerges. But bare metal cannot survive years of exposure to weather, road debris, and harsh operating conditions. The cab must now enter one of the most sophisticated paint facilities in the manufacturing process. Before receiving its final color, every surface is thoroughly cleaned and prepared. Soon, robotic painters will apply multiple protective layers, designed not only to improve appearance, but also to protect the vehicle for years to come. The transformation from raw steel to finished cab is almost complete. And the next stage may be the most visually impressive part of the entire Scania production process. After leaving the welding facility, the newly formed cab begins another critical stage of its journey. At this point, the structure is complete, but it still lacks protection. Without proper treatment, years of exposure to rain, snow, road salt, sunlight, and extreme temperatures would slowly damage the metal beneath. This is where the paint factory takes over. Before a single drop of paint is applied, every surface undergoes an extensive cleaning process. The cab is carefully washed, treated, and prepared to ensure perfect adhesion. Even the smallest contaminant can affect the final finish. Once preparation is complete, the cab enters a highly automated painting facility. Inside, advanced robotic systems perform nearly every stage of the process. Unlike human painters, robots can maintain perfect consistency hour after hour. Their movements are precise, their coverage is uniform, and every application follows exact specifications. The paint itself travels through a sophisticated distribution network that delivers precise amounts directly to each robot. As the cab moves through the line, multiple protective and decorative layers are applied. Each layer serves a different purpose. Some provide corrosion resistance, others improve durability, and the final layers create the appearance customers will see for years to come. Scania offers hundreds of color options, allowing customers to customize their vehicles according to operational needs or corporate branding. Once painting is complete, the cab passes through specialized curing ovens. Heat hardens the coating and creates a durable protective finish. After cooling, inspection teams begin one of the most detailed visual examinations in the factory. Every surface is checked. Every reflection is inspected. Even the smallest imperfection is identified and corrected before production continues. Only after passing these strict inspections can the cab move forward. The transformation is remarkable. What entered as bare steel now emerges as a finished exterior structure ready for final assembly. But there is still one major step remaining. The cab may look complete from the outside, yet inside, it is still empty. The dashboard, seats, electronics, controls, and comfort systems have yet to be installed. And this is where the truck finally begins to resemble the machine drivers will one day operate across highways and continents. With the cab painted and approved, the final assembly phase can begin. Inside the assembly workshop, teams work to transform the empty shell into a functional workplace for the driver. Wiring harnesses are installed, dashboard systems are fitted. Seats, controls, storage compartments, insulation materials, and electronic modules gradually fill the interior. Every component is carefully positioned and tested before the next stage begins. One particularly important operation involves the installation of the windscreen. Using specialized equipment and robotic assistance, technicians secure the glass with extreme precision. The process may appear simple. In reality, it plays a major role in structural integrity, visibility, weather protection, and overall safety. As the cab nears completion, attention returns to the chassis waiting at the main production plant. Soon, two separate manufacturing journeys will finally become one. This moment is known throughout the factory as one of the most spectacular stages of production. Using a specialized lifting system nicknamed the Eagle, the fully assembled cab is lifted into the air. Slowly and carefully, it moves above the waiting chassis. For a brief moment, the cab appears to float. Then, with incredible precision, it is lowered into position. The truck finally becomes a single machine. With the cab installed, workers move quickly to complete the remaining assembly operations. Protective covers are fitted. Exterior trim components are attached. Lighting systems are connected. Additional safety equipment is installed. Finally comes one of the most physically demanding tasks in the factory: wheel installation. Massive truck wheels are positioned using hydraulic lifting systems and specialized tools capable of applying exact tightening forces. Every wheel nut must reach a precise torque specification. Too little force could create safety risks. Too much force could damage components. By the end of this stage, the truck stands fully assembled. From the outside, it appears complete, yet before it can leave the factory, it must prove that every system functions exactly as intended. The final challenge is about to begin. A series of inspections and performance tests will determine whether this machine is ready for the road. For the first time since production began, the truck is ready to come alive. Technicians fill the vehicle with fuel, coolant, lubricants, and hydraulic fluids. Then comes a moment that thousands of components have been waiting for: the first engine start. After weeks of manufacturing and assembly, the machine finally produces its own power. But starting the engine is only the beginning. Before any truck can leave the factory, it must pass a long series of inspections and performance tests. Electronic systems are programmed and calibrated. Sensors communicate with control units. Diagnostic equipment checks every major function. The truck is then placed on specialized testing equipment designed to simulate real operating conditions. Brake systems are examined. Air pressure circuits are verified. Mechanical components are monitored under load. Engineers carefully review performance data to ensure everything operates within specification. Next comes a series of technical adjustments. Wheel alignment is checked. Lighting systems are calibrated. Safety equipment is verified. Electronic records are reviewed, and every critical function undergoes additional inspection. The vehicle then moves outside for a real-world evaluation. Professional testers drive the truck through a controlled environment. They assess steering response, braking performance, transmission behavior, electrical systems, and hydraulic operation. Even after these evaluations, the truck still cannot be released. A final inspection team performs one last comprehensive audit. Every wheel nut is checked. Every electrical system is tested. Every connection is inspected. Technicians search for scratches, leaks, loose components, assembly defects, and any deviation from factory standards. If a problem is discovered, the truck returns for correction. No exceptions. Only after passing every stage is the vehicle approved for delivery. The result is far more than a truck. It is the product of thousands of engineering decisions, countless quality checks, advanced robotics, skilled craftsmanship, and decades of manufacturing experience. From a pair of steel beams to a machine capable of hauling enormous loads across continents, the journey is extraordinary. And that is how one of the world's most respected heavy-duty trucks is built. This is Scania, and this is Engineering Giants.